This is a short video to demonstrate the PIC based oscilloscope that I've built. I did not come up with the circuit on my own. I used someone else's online schematics. I did make a couple small changes and built it in a very small form factor on a PCB that I used a laser printer to do the toner transfer method of getting the design to the circuit board, and I etched the board myself. So I'll show the board here real quick. I do have it currently hooked up to a battery, so I'll try to flip this around without blowing anything up. Give me just a second. Move my light over here. So this is the unit. Apologize for the lack of acrobatic skill here as I'm trying to maneuver the light and my camera. There's my probe connection right there. The wires coming out. I'm only using 2 of them. It's just jury-rigged for the moment. I'm just doing this to test it. There's a 27 megahertz oscillator, a 12F675 PIC microcontroller right there, and various other components. It's all powered off a 9-volt battery. Here's the video connection right there. The PIC is generating an audio signal, or a video signal rather, in software, and you can see on the screen here it's generating a signal. The processor, even when it's overclocked with a 25 megahertz crystal, it is still incapable of generating an NTSC signal in real time. It will generate a PAL signal. Luckily, my plasma display will display PAL. Of course, here's the back of the board. It's kind of hard to see detail on this device, but the components are labeled using a very small print, and the board was just manually tinned with a soldering iron. So I will go ahead and play around with it here a little bit. You can see on the screen here it's got a signal that's been displayed from earlier. I'm using Absinthe here, which is just a very simple way of generating different types of waveforms here. Right now I got it on a vocal sample, so I can key it up and display the signal live here. Likewise, I can change to a sine wave here and view the sine wave in real time. Down here, this is the indicator that I'm working with 13 milliseconds from left to right. Along the bottom here there are 10 divisions, so I can tell that each of these is going to be 1.3 milliseconds across. Likewise, I can switch over to a triangle wave and view the triangle wave. And I can also do square wave and the expected square wave. Actually, it's not a perfect square wave on this software. It looks like it's tapered a little bit. And do some more complex waveforms, modified square wave there. So, all in all, it's a pretty interesting device for being this size. It is limited on its sampling rate, though. It won't quite do 1 megahertz, but it's good enough for my purposes. And I hope to eventually get this finished, put actual push buttons on here instead of having to jumper those with a screwdriver or something to make the changes. That's these right here are just for the up and down settings, as well as to change the cursor on the screen here. The cursor is the underline. I can change the time value, and I likewise can change the level and such along the side there. So just a quick video, and the schematics are available online. You can just do a search for 12F675 oscilloscope, and you'll probably find a link to the gentleman's site that had the original circuit, and feel free to build it. It's a fun little project, and it is a useful tool.